Guys, so I'm gonna teach you matrices in like a short while, and I'm gonna introduce the basics. So a matrix is, let's say, a row of column and numbers. These are letters, but they're numbers, and we do operations with them. There's an m by n matrix where m is the number of rows, and n is the number of columns here. So we matrices can be treated like real numbers. We can just add them. So let's just assume there is a matrix like this, and there's a matrix like, okay. So we can add them if they have the same number of rows and if they have the same number of columns. If this is an m by n matrix, this should also be an m by n matrix. And we just gotta add them here. So 5, 3, 7, 9, 12, 12. This is the addition. When we subtract matrices, let me make it a little smaller so I can fit all of these things. I can fit everything here. Let's just try another matrix. So if you want to subtract the same matrix over, uh, what do we do? Well, we just do the same thing, except for we subtract the corresponding row and corresponding column. So we can write it like something like this. Yeah. If this is matrix A and this is matrix B, so we can write it something like this and this, where this is the number of rows, the number of columns. This is the same thing, but a little different way writing it. 2 minus 6 minus 4. So just like you can see that the which number you're talking about. The matrix. So minus 8 minus 8, 1 minus 1. Sorry, 1. This is how you subtract matrices. Want to multiply a scalar with one matrix? Sorry, why did I erase this? Anyways, if you want to multiply a scalar with a matrix, then you just gotta multiply the scalar with every part of the matrix. So like 6, 3 2s are 6, 2 2s are 4, 0, 8, 10, and 12, right? Dividing is the same thing over, except you just divide. You got it right. You probably get this last part. Only 5 over 3 and 2. I hope that was clear. Now, when we're talking about matrix multiplication, like two matrices multiplying with each other, let's say 3, 2, 0, 4. There should be one condition that should be fulfilled. It's that the number, if this is an m by n matrix, there should be an n by m matrix. Number of rows of this should be number of columns of this, number of columns of this, number of rows of this. So I have 2, 1, 0, 5, 7, 9. If you have an n by n matrix, that just makes things simpler, and you get the product as an n by n matrix. But thing is, you get either an m by n matrix or an n by n matrix, depending on which is bit. So I'll just say it's an n by n matrix where n is greater than m. We don't actually define what is m. Wait a second. This is an m by n matrix. Number of rows are 3 and number of columns are 2. Sorry. Number of rows are 3 in this one. Number of columns are 3. So this is an m by n matrix because m we defined as greater. So m is greater than n. So I'll tell you what it was. This component with this 6 first with first 3 2s are 6 plus 2 5s are 10. 16, 3 1s are 3 plus 7 2s are 14, uh, which is 17 here, right? Yeah. Then 3 zeros are 0 plus 2 9s are 18, just gives you this. So it's going to be a 3 by 3 matrix, right? 3 by 3 matrix. 20, 28, 0 makes it easier for us. 36, 10 plus 30, 45 plus 42, 47, and 54. This is what I'm going to get if I multiply matrix. If it's an n by n matrix, just assume it's this and this. Then it's this, gotta be one term, this, another term, this, one term, this, another term, 4 terms, and it's gonna be the same thing. The number of rows and columns are different. And when you have a square, these are called square matrices, by the way. And why did I put that? Really? This one I shouldn't have. I shouldn't have really, you know, subtracted this one. Just wait a second. I'm going to pause the video. I'm just going to read it again so you can copy notes or something. Yes. So this is like a generalized form for like 2 by 3 and 3 by 2. Okay? Yeah, but again, there's a thing. If you multiply this with this, if I multiply a by b, it's not equal to b by a. There is a different commutativity, and we can prove this. But I am on a short time schedule, so I'm gonna just tell you what the determinant of a matrix. Determinant of a matrix. Let's just say it's this matrix right here. Is a general form. It's basically AD minus BC, the diagonal, the multiplication. We're talking about 2 by 2 matrices. You multiply the both sides of this forward diagonal. This is the diagonal you deal with minus BC, right? This is my determinant. So if it's like 1024, uh, if it's 1024, then it's gonna be determinant is gonna be it's like a value which you use for these stuff. 4. If it was a negative value, let's just say instead of 2, it was 3. 4 minus 6. Then you get what the absolute sign basically means. It's going to be 2. For inverse of matrices, for inverse of a 2 by 2 matrix, we just divide by the determinant. And if it's going to be this, so instead of this form, this is the normal form of the matrix, we gonna switch these signs. The forward diagonal is going to switch them like D and A. And B and C are just going to switch their signs. So if they're already negative, you just add a negative sign, which makes it change. This is the form of an invertible matrix. But what if, I don't know, it was this? What if determinant is 0? Then you can't get a matrix with an inverse. So these are called singular matrices, in which there is no determinant. There is no determinant is 0 and there is no inverse of a matrix. No inverse exists. Okay. What about 3 by 3 matrices? I would like to talk about is that I'm gonna erase this part, right? I hope you just take a picture or copy this, or just you've understood what I've taught you here. I'm gonna erase this part real quick. So a 3 by 3 matrices. We're talking about n by n matrices. So because square matrices have much more properties that we can you know imply on matrices. Let's take a 3 by 3 matrix like 1, 2, 3, 4, 5, 6, 7, 8, 9. Simple. And we want to find its determinant. First, basically, you just choose any row. Let me make it more a little more random. Yeah, I'm gonna choose any row which is gonna be like easy for me. So it's basically gonna be. Let's just choose this column because this thing is 0 already, so it's gonna make things easier for me. But just to explain you, I'm gonna choose this row. Just choose the row which makes things easier for you. I'm gonna choose this row. Okay, row or column. You can choose anything. I'm gonna choose this column, so I'm gonna multiply by 5. Then I'm gonna find the determinant AD minus BC of this corresponding the cofactor basically, which does not lie on 5's row or 5's column. Okay. And what do we do? Find AD minus BC. 12 minus 7, which is 12 minus 7. 12 minus 0. 7 times 0. Then here. Thing is between cofactors, the adjoint basically of matrix, or 3 by 3 matrix, you change the sign. It's supposed to be plus, then negative, just keeps on changing. But right now here 4 doesn't lie in its row or doesn't lie in its column. So 7, 1 and 0, 6. 7, 6 are 42 minus 0. Again minus 0. Then we have a positive sign. Guess what? No row bars which are not in the row or the column of 9. 7 sevens are 49 minus 2. Finally, something that does not have this uh, marker that's working. Yeah, so it's basically this word 7, 49 minus 2. 7, 49 minus 2, 47. 12, 42, 47, 12 5s are 60. 60 minus, I don't know, 168, which is gonna give me minus 108 plus 108 plus 47 times 7. 47 times 7 is like 280, 49, and then that's gonna give me 329. And this was minus 108. So the total answer that I'm gonna get out of this is 221. Determinant of matrix. We divide them into smaller 2 by 2 matrices. Don't remember to use the negative sign. Okay, I'm gonna make another videos on vectors because that's also interesting. But this was basically it. There's some other stuff that I'm gonna introduce to you later. Thanks, guys.